Hi, welcome to Mobile DevOps Summit 2022. I'll talk about native mobile automation toolings for mobile apps, and our motto will be part of the development team by native way. So this is me. My name is Mesut. I'm based in Turkey. I'm a principal consultant at Modus Create, and I'm a blogger. You can find me in the internet and the social media with these IDs and the URLs. And this is the topics. And I'll talk about mostly test automation and mobile testing, but I will also define the mobile testing toolings, native and non-native toolings, also benefits of native toolings. And this is the agenda. In the first part, I will mostly define the mobile ecosystem, mobile automation ecosystem, and then native and non-native solutions. And in the second part, I'll talk about the benefits. And those are handling the objects, performance, and the team buildings. Okay, let's start with mobile automation ecosystem. Basically, mobile applications are packages and binaries that can be installed on any target devices to let the user do what we want. And the mobile application testing is also installing the application in a device and then performing the test steps one by one. So the automation means that all the things that should be done for manual testing should be done by tools and scripts. And so because of this, we need some toolings and some scripts and some requirements. And basically we need an APK, an app or IPA, and which means that we should have an application package, and also we should have a mobile device. It can be a real device or emulator or simulator. And also we should need network and also require permissions. And also depend on the apps, we should also need extra requirements. Okay, let's talk about test levels and test types. This is a matrix. It's showing the test types and the test levels. You can imagine that the test pyramid differently. This is a redefinition of the test pyramids. And you can see that different test levels on the left and different test types. Test type can be functional and non-functionals. And the test level can be unit, integration, or system and acceptance level. You can perform functional test in the unit level as a unit test, or you can do some non-functional test like load stress or checking some metrics or code coverages. And so this is the unit level testing. And when the aim of this presentation is to understand the XCUITest on the system level. So it is the test we want to cover in this presentation is about functional testing on the system level, and it will be the end-to-end test. And so what to automate? After checking all the tests on the matrix, we can talk about the aim of the automation. So first, we should identify the purpose of the test automation to not to lose the focus and not to focus on another area. So what should we automate? So in terms of automation, we should automate everything that is meaningful and possible. Most probably everything is possible to automate, but in terms of maintainability, it might be expensive. So instead of this, we should check the test cases if it is meaningful and if it is possible. So basically, we can automate the classes and methods in a unit level, or in an integration level, we can automate the unit integration component of the system integration test. And also we can automate the requirements like functional and the non-functional requirements. And also the process sometimes taking long time. if we do it manually. So we can automate the software development process and software testing process, or software or the application distribution process. Okay, let's talk about how we can automate those things. Basically, for this presentation, we are just focusing on the end-to-end test automation. So the end-to-end automation can be done only by the toolings, and the toolings that can be interact with the elements on the application. And basically, in terms of mobile application automation toolings, we have two kinds of automation toolings. First one is native tooling, and the second one is non-native toolings. And the native tooling is a tooling that is available with the development frameworks. And the non-native toolings that is focusing on the automating the mobile application, but those toolings are kind of third-party toolings and external toolings that should be integrated into your automation framework, and then you can do the automation. Okay, and the first kind of mobile automation tooling is non-native solutions, non-native automation toolings. Let's talk about non-native automation toolings. We are saying non-native toolings because it is not inside the development framework itself. It is not an internal library. So it is an external library that can handle the mobile automation, and the mobile automation is the tools itself requires servers to make the connection between your application and your automation solution, and the overall system is a black box. So you can apply only the black box testing techniques. There's an app, it's a build app, and your automation solution is here. The connection can be done through the HTTP server, and then the application can be tested within the application server. So basically, there are two kind of dependencies. First one is the HTTP server in between your application and automation solution, and also those non-native solution requires native libraries. And those native libraries come with the application, which means that the non-native solution also uses the native solutions. Shortly, the native solution that non-native toolings use are Espresso and XCUITest. Okay, let's talk about how non-native toolings works. I just define it. Let's go deep into the architecture. So basically, there should be an HTTP server in between your application and your automation client to convert automation commands into the understandable application command. So interaction can be done in two ways. The first one, as I said, the interaction can be done using the native libraries. For Android, it can be Espresso, UI Automator, or UI Automator 2. Also can be Appium. And for the iOS part, it can be XCUITest, and it can be an UI automation. And the second kind of interaction can be done by image recognition. So there's an HTTP server in between your application and the automation code. When the command come to your application, it takes a screenshot of your application screen, and then take the relevant part of your application screen. For example, if there's a button, then it checks the button image in there, and then give a name of it, and then you can use it in your automation script. So basically, it's an image recognition process, and it takes longer time. Also, it requires much more memory. Okay, so for now we have talked about the non-native solutions, And Appium is the most known and the most popular non-native automation solution. It is popularity come from the Selenium WebDriver, and the Appium is developed on top of the Selenium WebDriver, which means that it has the functionality of the Selenium WebDriver, which means that it is also supporting multiple languages like Python, Java, Ruby, PHP, JavaScript. Whatever languages you use, it is most probably supported by the Appium because of the Selenium WebDriver. Also, Appium also supports multiple platforms like Android, iOS, and Windows, and it is open source, which means that there are a lot of framework developed for automating and using Selenium and the Appium for different projects. So basically, you will have only one project with your popular languages like Python, Java, and then you will use it for automating Android, iOS, and the Windows application altogether. And what is better is that you can also use only one test case folder or file to drive all your testing for different platforms. I think this is the great part of the Appium. And let's talk about the architecture little bit more. And as I said, Appium is non-native automation toolings, and Appium requires native automation toolings libraries to make the automation available for you. So basically, you can see that on the left, this is your automation solution on your local laptop, and you can use any languages. Java, PHP, C#, Python, whatever you want to use. And then when you send a simple command like click, it will go to the Appium server via the JSON wire protocol, and this is the first part that your command will be converted into the Appium server command, and then Appium server command will send this command to Appium driver, and Appium driver has two kind of driver. It can be Android or iOS driver, and when it comes to the Appium driver, then it is ready to interact with your application. For the Android one, it uses the Espresso or the UI automator to interact with the UI elements. So basically, when it comes to the application and in a device, then it uses the Bootstrap jar for the Android, and for the iOS, it uses the Bootstrap JS to make the interaction available, and it also uses the native libraries. So when the interaction is done, then it will send the response back to your client. So the interaction is bidirectional. So your command will come to application, and then it will be returned back to your automation client. So which means that you are sending and you are receiving the responses, and you are checking the responses if it is something you are expected. So basically, this is kind of over engineering toolings because of these extra steps and extra implementation, and it also uses some native libraries. Okay, let's define the call steps for the iOS for Appium. You can see that there are lots of steps on the right, and when you send a simple command, it should go through this way, and then when it's reached to the application in a device, then it should send the response back to your application. So which means that all the steps, all the toolings and the libraries should be idle and waiting for your command. So if something wrong within these steps, then it would be fail. And there is also workaround that you can do. You can check the result of your command and if it is not something that you are waiting, and if it is failed because of these steps, then you can retrigger the command and then to check to make your steps more robust. And this is something time consuming, as you can see. The simple command goes through all those libraries to make the command available for you. So basically this kind of architecture can be flaky, and it's actually deemed to be flaky because of the requirement. It requires lots of libraries and lots of steps, lots of translation of command. So this journey is two ways. I mean, when the commands come to here, and it should return back to your automation client. And as I said, it is time consuming, but but you can use your favorite languages, and you can also use it for different platform, and you can also use just only one project. This is the great part of the Appium, but this over-engineered part is kinda problem for the Appium. When I go to the deep into the implementation of Appium, you can see that all those toolings have been done by Appium community, and you can see that if something wrong with the library or the toolings itself, then your automation stop. Basically, it will be stopped. And as a tradition, every year Apple and the Google release new feature, and this new feature should be covered by Appium community to make it will be available for you to use that functionality in the Appium project. But sometimes it is hard, and sometimes it is not possible also. So you should be careful about this one. I can easily say that the Appium is very, very over-engineered tool because of this architecture. But it works. So let's talk about another non-native automation tooling, Calabash. The Calabash is older than Appium, but it is not as much as popular as Appium, because the Appium has different capabilities, like it supports many different languages, but the Calabash is only supporting the Ruby. The Ruby is so it is popular in the Ruby community. But what is good about the Calabash is Calabash has out of the box Cucumber integration that means that you can write your test cases in a BDD style very easily, and then there's a great CLI tooling support that you can run your test cases in a CLI and easily integrate into your continuous integration environment, and then you can run it in any cloud services. Basically, it is also open source. It has Android and iOS, Calabash Android and Calabash Android iOS version. But unfortunately, Calabash is almost dead because the community is not supporting enough yet, and then there have been some features not implemented into the latest version. So people still are using it because they have used it in many places, so it is still used by them. So let's talk about the architecture. This can give an idea for you. You might not use the Calabash, but it can give an idea how a non-native toolings can be implemented. The architecture is very similar with Selenium and with the Appium. You can see that there is also a server. It is called instrumentation server this time, and the instrumentation server translate your comment into the app, and the Calabash also used Robotium for Android and XCUITest native libraries for the iOS. So all the tests triggered by is triggered by the feature file. Feature file has some test cases, and then it triggered the step definition, and the step definition interact with the instrumentation server that is inside your app, your device, and then the instrumentation server connect with your app to execute the command in the app. So let's talk about the native solution. We have talked about the non-native one, and let's switch to native solution, and you can see the great part. So what is native toolings? And the native tooling is an integrated libraries, and which is come with the development framework itself. So you don't need to install an external toolings or external libraries in your project. It is inside your development project, and it supports it supports many benefits, like the API is always ready for you, and you can know the state of the elements with the API. So these are the great part of the native toolings. Basically, we are talking about two major platforms, Android and iOS. So for the Android one, we will explain the Espresso, and for the iOS part, and also we will talk about XCUITest. So basically, native solution comes with the development framework, so it is always guaranteed that every new feature is covered, and you can automate it easily with the native toolings, because Apple and the Google give promises about this. So how native toolings works? Basically, native toolings is a part of your project, and which means that everything in the project is available to you. So the API knows the state of the element, and you can directly interact with the UI elements. And with this one, you can write, you can apply not only white box testing techniques, but also black box testing techniques. And you can imagine that whole application is kind of matrix, and the native toolings are the agents inside the matrix, which means that you can do everything whatever you want. Even you can update the source code for the sake of the better UI test. Okay, the first native solution is Espresso. Let's talk about Espresso. Espresso is the UI testing toolings developed by Google for the Android UI automation. And Espresso is also open source and very stable. And you can find many different framework to develop the Espresso test. So also Espresso has JUnit functionality, and you can get benefit of JUnit in your test, like tagging, annotation, or setup and tear down functionality. And the Espresso is in part of your development framework, which means that the Android Studio is the IDE that you will use it, and Espresso has everything for you. For example, when you define the dependencies in your dependency file, then you are, if you say Gradle build, then the then the Gradle will install everything you need. So no need to do extra thing for it. So it supports white box testing techniques also. So what Google says about the Espresso is that if you want to write a full powered UI test as a developer, then the Espresso is the tool that you want to use. Okay, let's talk about how we can implement simple Espresso test. Or this is a simple application. It is a dictionary. It is test risk dictionary. So you can see that different packages on the left pane, like the application source code, and then application UI automation code, and also application unit test code. So basically, you can use Kotlin or Java with for your project, which means that you should apply some best practices like solid, like dry, or you can also apply some best practices for the test automation part, like page object models. So in this example, in this simple example, we also apply the page object model and also other solid and dry practices. So basically, we have home screen. The page object model is basically designed for the web project, so that's why it's called page and object. But for the mobile application, we are now talking about the screens instead of pages. So this is the home screen class. Home screen class has everything that you need for the automating the home screen functionality. So in the first part, you will define the elements by directly calling the Espresso and the IDs of the elements. So base screen class is inherited from the base screen class, and the base screen is the class that is including everything related to your screens. So you can use it as a base class to get the functionality, to get the basic functionality for your classes. And this home screen class has also the methods, the test methods that you will use in the test class. And this is the basic implementation of your class, of your screen. And this part is the testing part. So basically, there is also a base test class. Base test class is the class as the same with the base screen. It includes everything related to testing your screens. And this is the screen, the dictionary screens, and it is inherited from the base test class. And this is the class that is implementing the test. So it has the setup function, and this is the JUnit, and you can use every JUnit functionality in your test class. So in the setup, I need to go to the dictionary screen in the setup. So in the setup, I will just define the variable and just call the method to go to the dictionary part. So in the test part, everything is ready and I can start testing on the screen, on the dictionary screen. And in the dictionary screen, I'm using the dictionary object and created by the dictionary screen. So I can call the method that is defined in the dictionary class, like here. So this is the basic explanation for the page object model, and the page object model just aims to reduce the maintenance effort by dividing the responsibility. For example, the API calling is only happening on the page model, page object, on the page class or the screen class. And everything regarding your testing is just in the test folder. So when you need to update the test, you can just need to update here. If there is something wrong with your element or your functionality, then you just go to the screen class and then update in there. And this is another test class. It is also inherited from the base test. And then you can call it, you can call the other methods in other pages, other screens. So basically, since this is a simple app, and there is also a simple unit test, and the unit test is defined in the unit test package. So basically, the Espresso, you can apply the white box testing techniques, which means that you can free to check the source code to make your test more robust, and also you are free to check the unit test. Basically, what test pyramid is saying is that you should cover as much as test cases in the low level of your system. With the low level, you can remember that the test pyramid, the lowest level of your system is the unit, and then integration, and then UI. And if you can cover a test cases in the unit level, which is more faster and more robust and more better, it should cover in there. But if you want to test the user journey, like what user want to do on the UI level, then it should be covered on the UI test code. Okay, let's talk about the second UI automation, mobile native automation tooling is XCUITest. And XCUITest is very similar to Espresso. It is also it stands for Xcode user interface testing for iOS application, and it is developed by Apple in 2015. It is also native and inside your project, which means that you can apply the white box testing techniques as well as black box testing techniques, and it is native. It is inside your application source code. So you should also use the Xcode, and Xcode will handle everything related to testing, and everything will be ready to you. And also XCUITest uses the accessibility, which means that the interaction is done by the UI interaction library, and it is very nature. And let's talk about how we can write simple XCUITest. I am saying simple, but the architecture itself simple. You can write very complex tests within this architecture. So it is very similar to Android one. Again, you have test target, you have application source code here, and then you have UI test code, and you have different package for the unit test code. And similarly, the page object model is also applied here. You can see the similarity because we apply the same approach and we apply the same syntax. So there's only one difference. The XCUITest is using the Swift, but the Espresso was using the Kotlin. So you can see that base screen is the screen that is including everything related to basic functionality of each screens. So this is a home screen inherited from the base screen, and it has all the elements, all the functionality, all the methods that you will require while writing your test. And there's also base test, and the base test inherited from the XCTest cases test case class, and the XCTest case class is the class that is architected for writing better test. It can be unit or any test, so it has many different capabilities. So this is the base test, and it has everything required for your apps. App testing, for example, you can define the app by an XUI application, and you can define some constant, and you can also define some setup in here. When I come to the test and the final, it will be inherited from the base test, and you will define some object from the base screen, from the screen that you want to test. For example, this is the home screen object created with the home screen class, and I'm just calling the setup function to get ready my application for testing, and I'm just using the test. It is very similar with the Espresso. Okay, I finished the first part, and the second part will be mostly the benefit. Okay, let's talk about the handling the object. Sorry. So the native automation tooling is inside the application. So which means that every element is available to you natively, which means that there is no server connection in between your elements and your automation project to translate it. And XCUITest and the Espresso provides many benefits. Like API provides the methods for all kind of elements, all kind of object. Like it can be button, it can be text box, it can be input, it can be anything. If there is something newly released object, and it will be supported by the Espresso and XCUITest. So which will be very difficult for the Appium or the Calabash part. I should wait until it will be supported by the Appium community or Calabash community. So which means that always it is up to date with the latest update. And also I can update the source code for the sake of better UI test. So everything is natively available to me. And also IDs are very friendly, and you can see that for these simple test cases, I just put a debug point at line 22, and I want to check some condition in there. So when I run the application, run the test, when it comes to this point, it will stop, and open the debugging pane for me and waiting for the execution of command. And since the base screen has already passed and it is built, then everything in the base screen is available to me. For example, the app was implemented in the base screen and it is available in the pane, the debugging pane. So with this way, I can call the API, for example, the buttons, and then when I give the text of the buttons, then the object will be available to me. So this is basically interactive test and debugging way of your testing, and it is very easy and it is very mature. So you can easily find the best command for your test and then update your test code. So another benefits of native tooling is performance. You will see the great performance. So basically, for native tooling, we don't have servers. Servers is the only way that non-native tooling can interact with your application elements. So which requires some translation of your command, and also requires some time to translate it. And it will travel all through your different libraries and toolings, and then it will be received to the target device and target application. So this is time consuming and this will be flaky. And so you should cover this kind of flakings by adding extra code, extra weight, and it will be reduced to performance drastically, because finally your test might require extra time to handle the different cases, and also it requires to be idle all the steps in the servers. So basically there is a work has been done by Test Project. Test Project is another company, and then it provides some services. So it compares the different toolings performance. For example, Espresso can be compared with Appium, and also XCUITest can be compared with Appium. So you can see that Espresso consumes almost 300 milliseconds. But when I come to Appium, it will be almost double of Espresso. The similar way, when I compare to XCUITest, you can see that the difference is more than double. And this is this is just for a simple comment. For example, when I compare the click comment, you will see that the for example, when you wait 200 milliseconds for Espresso, then it will be 500 seconds for Appium, for a simple command. And you can imagine that for a simple test cases, you might require this kind of command maybe 100 times. For a great project, it might be 100 or 1,000 different command calling. So there is also another work have been done by South Lab, and you can see the great difference in the performance. So basically, this is the call step for Appium, and for this work, the Appium client is in the CI and it is located in Houston. It is this part. And also there is an Appium server in the cloud service, and it is located in San Jose. In the distance between Houston and San Jose is around 1,700 miles. So simple command should travel this path. It is 1,700 miles and it should return back to your client, and another 1,700 miles. You can see that, okay, this is the speed of internet, but it is still consuming some time. And you can imagine that all the native activities is just calling an API into the same project, but in the Appium side, it is just traveling for 3,400 miles. And when I compare these two into local, it will not affect much. But when I compare, when in an ideal way, which is I have an CI and I also have some cloud services to run my test cases. So which means that when I go through this path, and it will be consuming a lot of time. In my personal experience, for a 100 test cases, for the native solution, it was taking 10 minutes, but it was taking around 100 minutes for the Appium one. So you can see the difference. It is 10 times more. So the last benefit is team building. Let's talk about team buildings. And I think this is one of the great way for using native mobile automation solution, because we defined the native, what is native, which means that the automation, UI automation code, which is mostly responsible of QA or STAT or test team, is inside the application project itself, which means that every team members, including QA engineers or STAT, is also contributing to the same project. And this is the way that they can learn the application better. You can imagine that one simple merge request has to be approved by some developers, and they should take care of these test casing process also. And the developers should have some knowledge of how to write UI test. And similarly, the QA engineers or who writes the UI test also has knowledge of how the application developed, how a simple feature can be implemented, and how a base object or the UI element can be updated. Because for every simple things, I cannot go to developer to make those changing, because I am in the project. You can imagine that maybe in the first part and the first year, it might be difficult, but after some time, let's say 2-3 years, I think a QA engineer can be also a developer, or can be can have some experience as much as a developer can do. So which means that the absence of one role, for example, a developer might go to a vacation, a short vacation, and there are some feature are waiting to be implemented, or some bug or some defect should be fixed during this time. So QA engineers or the estate can be bridged this time to do this kind of stuff, the basic stuff. It can be done by any engineers in the team, because it can be cross-functional within the team, and it is native toolings, because everyone can see the source code and contribute to the same source code, and everyone in the team should all the notation, all the best practices about how to develop, how to write test, how to build the application, how to test the application, how to deliver the application. And this is the basic information and the basic experience within the development team. So basically this is called cross-functional team. Every member in the team has at least basic knowledge, basic experience for the software development, and then he can contribute to the team when there is an absence, there is a miss of some roles. The similar way, a developer can fill the absence of QA engineers by writing code. Not only writing automation code, but also doing some functional tests on the code. So which means that teams can do everything related to team by their service. And this is a way of building a team around the quality. And there should be a team sprint. The team sprint will say that everything I need to do for the team should be learned by me, and I should do everything when I need it. So basically this is the cross-functionality. And I can give an example with the cross-functionality. I was lucky because I get lots of feedbacks from experienced mobile developers, and this is when I am just experiencing with the mobile development, and the guys were very friendly and helped me a lot. So this is the one of the feature of the cross-functionality. You can imagine that the guy can be a senior in one area, but he can be a junior in another area. So you can trust him, and you can believe that he can do some other part of the development task. So basically, I got great feedback from the experienced mobile developer, and I implemented some part of it in my project. But at some point, I need to take a rest, and I went for a vacation. So I just give it to another friend of mine from the QA engineering team, and he continued to fix the rest of the PR. And finally, there was a great job, because developer helped me to create a great framework, and I just contributing the testing part to make better testing approaches. So developer is a kind of genius one in the team to make the code more better, and our framework can be better. And also I contributed to the testing part to give an idea how we can write better testing. So this is another great point of the building team around quality. So I am done. Please ask me question now. Thank you.